Welcome friends in the next session of signals and systems. Different forms of the Fourier series that we'll discuss. So these are the formulas which will give us the information about how to calculate the frequencies in a given signal using Fourier series. So first form of Fourier series, which is very popular, is called as Trigonometric Fourier series. It's called as a Trigonometric Fourier series, and just try to understand here that what is the meaning of this equation. So first is x of t. The x of t is the periodic signal. It's a periodic function that we wanted to express in terms of sine and cosine. Alright. So this x of t we can express as first component is a0. A0 is a constant and it is a DC term of a periodic signal. DC term means its average value of the signal. The average value can be 1 volt, 5 volt, it can be minus 5 volt, etc. It can be 0 volt also, right? So A0. Then second term is this one. So please understand this, it's very important. The second term is your cosine term. Second term is a cosine term. Then we have the third term over here, and the third term is your sine term. So what we did, we expressed x of t, which is a periodic function. Remember, we are discussing Fourier series, so we will consider only periodic signal. Non-periodic signal cannot be estimated with the help of Fourier series. We have to use Fourier transform for that, right? So three terms we have used to express the periodic signal. Number one, A0. A0 is the average value of the signal, or it is also called as DC value of the signal, right? Then second term is all cosine signals, cosine component, and third component is a sine component, right? So average plus cosine plus sine, these are the three terms that we are using to represent our periodic signal. Now let us see more details. So first term is a constant A0, so it's very simple to understand. Let's see the second pair. Now second pair is a cosine term. This cosine term has some magnitude, right? Some amplitude it may have. So this amplitude is represented by AN. AN indicates the amplitude of cosine term. Now what is small n indicates? Small n is your frequency component number, or it is called as harmonic number. You can please take a note of this. Small n over here is called as harmonic number. So if n is 1, it's a first pair of cosine term, A1. Then next A2, A3, A4 and so on. If there are 5 cosine components present in any periodic function, then you can get A1 value, A2 value, A3 value, A4 value and A5 value. That's it. So your n changes from 1 to 5. So if you wanted to develop a generic equation, we can have all the values, all the possibilities, infinite possibilities. So what we did, we stated n as summation of 1 to infinity. So A1 to A infinity, it can have infinity value ideally we are considering, but in practical we may get only few values, 5 values, 10 values, 100 values and so on, right? So the second term I wanted to emphasize again that it is summation. Why summation? Because it is cos 1t plus cos 2t plus cos 3t plus cos 4t and so on. These are all sinusoids, summation of components. So there is a summation sign. So there is a summation sign, and n is a variable. N changes from 1 to infinity. There can be infinite components of cosine wave. That provision we have made. An. What is an? It's an amplitude of cosine term. If n is 1, it is A1. It's the amplitude of first component of cosine, right? Then cos 2 pi nt upon t0. 2 pi is a constant. Small n in against the harmonic number. If n is 1, it is cos 2 pi 1t. If n is 2, it is second pair of cosine signal. Cos 2 pi 2t. Okay. Now what is small t? Small t is a time instant. Like in MATLAB, we have seen that time period changes from 0 to 10 seconds in steps of 0.01. Right? So this time is an instantaneous factor that is changing. Upon capital T0, what is capital T0? Is a fundamental frequency of the signal. Like there is a fundamental time period T0 completing one cycle. So that is T0. So that's very simple. So it is summation of n from 1 to infinity n cos 2 pi nt upon T0. That's the second term. Similarly, we have the third term that we can write as summation n equal to 1 to infinity. Instead of n, we'll write bn because it's a value of sine component. bn sine 2 pi nt upon T0. Everything remains same. Instead of n, we have used bn, and instead of cos, it will be sine term, and rest everything is same. So these three are the values. These three are the terms that we are using to represent our signal. Now, what is the main thing? Main thing is that here how you can find out A0, AN and BN. That is what is a calculation of Fourier coefficient, and that's the main question that you have to solve it. So in Fourier series, you should be able to solve A0 value, AN value and BN value. I again repeat, A0 is your average value of the signal. This is the average value. N is the amplitude of cosine terms, and Bn is the amplitude of sine terms. Clear? How to calculate these terms? So these are the formulas. So first formula, A0. What we need to do? 1 upon T0. So T0 is known. It is fundamental time period of the signal, periodic signal. It can be 2 seconds. It can be 10 seconds. So it's some constant number. So 1 upon T0, you have to integrate over a fundamental period. Okay, over one period. Integrate x of t dt. So there is a signal x of t which is given to you. For example, a square wave. So you take a fundamental period, integrate the signal and divide by T0. So that will give you the average value of a signal. Then second component, amplitude AN. So AN is basically the amplitude of cosine term. So what we are doing, we are keeping the formula as 2 upon T0, integration over a fundamental period, x of t multiplied by cosine term, cos 2 pi nt upon T0 dt. So what is this formula? There is a signal square wave and we are taking cosine signal and we are just correlating whether it is matching it or not, and how many cosine, if it is matching, cosine term is present in the signal. If it is not matching, the answer is 0. Got this? So AN is magnitude, or you can say amplitude of cosine term. And how to find out that amplitude? Using this formula. The formula is 2 upon T0 integration x of t cos 2 pi nt upon T0 dt. Similarly, the third component Bn is same with respect to n. It is 2 upon T0 integration over a fundamental period x of t. Now instead of cos, we are using sine term because we want to correlate with sine component, whether sine frequencies are present or not. So integration x of t sine 2 pi nt upon T0 dt. So that's how we calculate A0, AN and Bn, and we get some information. So if you solve these formulas for any periodic function, you get some answers. For example, A0, if it comes out to be 2, so average value of that periodic signal is 2 volts. That can be your conclusion. Or if it is 0, then you can say that there is no average value, or average value is 0 volts. That's first thing. AN and BN, these values will come in terms of n, small n. Okay, as your n changes, n is 1, it's a first pair, it's a first harmonic. N is 2, second harmonic. N is 3, third harmonic. Right? So if your frequency is 1 kilohertz, then if n is 1, it is 1 kilohertz into 1. That is 1 kilohertz component. So what is amplitude of 1 kilohertz component? Say 5 volt for a square wave signal. Then if you put n equal to 2, n can be 0, So you can conclude that there is no second harmonic present in the signal. Then you put n equal to 3, you get some answer, and the value comes out to be say 4.9 volts. You can say that there is 3 kilohertz frequency, because for n equal to 3 there is answer. So 1 kilohertz into 3, that is the frequency, which is 3 kilohertz, and you are getting some amplitude, right? So what you are getting over here, that on x-axis you are getting the frequency, and on the y-axis you are getting the amplitudes, and you are getting the graph like this. See, so this is n equal to 1, 2, 3 and 4, okay, and these are the amplitudes. Now some interesting facts that will help you out to solve the problem quickly. Please understand that this trigonometric Fourier series is also known as Quadrature Fourier Series. Another name is Quadrature Fourier Series. And if your signal x of t is even function, say for example, your signal is like this. So this particular signal x of t is an even function, right? Because it is symmetrical about y-axis. If you flip it around vertical y-axis, it is still same. X of t is equal to x of minus t for this particular function. So if your signal is even, then no need to calculate Bn, because Bn is 0. Remember, Bn is corresponds to your sine wave component, and sine is odd. So if your signal x of t is even, Bn, which is concerned with the sine wave, which is odd function, Bn is 0. No need to calculate. You can simply write down, since the given function x of t is even, Bn is 0. So these tricks you can definitely use it, because these are all proven in your problem solving activity. Similarly, if your x of t is odd, for example, you have a triangular pulse, or you can draw one more square signal, and it can be drawn like this. So this is an odd function, right? If you flip it, x of t is x of minus t. Then your a0 and an are 0, no average value and no cos component value, which is even function. If function is odd, only Bn is present. Only calculate Bn. So out of 3 coefficients, 2 coefficients are 0, and only 1 coefficient you need to solve it. Similarly, for even function, Bn is 0. So just calculate a0 and an, only 2. So these are very interesting, facts that you can remember. And third one, if the mean value of x of t is 0, then a0 is 0. Naturally, mean is average. If any signal gives you average 0, then a0 need not to calculate. It's 0 by default. Got this? Okay, so hope you understood the first form of trigonometric Fourier series, and this trigonometric Fourier series is used to estimate this a0, an and bn components, and once we can estimate these 3 components, we will be in a position to find out what frequencies are present in the given signal. Alright? Okay.